As was mentioned, Carlos Olea and I'll be presenting our work on evaluating persona prompting for question answering tasks. So I'm sure, as is no surprise to anyone here, LLMs have become a particularly powerful and popular tool for generative AI, specifically since the fall of 2022. They serve as vast knowledge stores, and they have the ability to generate specialized and responsive text, making them a particularly powerful and versatile tool. However, we still need to study, and it is still being studied, the ability to fully utilize them. And one of the ways to utilize them includes assigning personas or using multiple agents, which are topics we will be exploring in this paper. As far as previous work, there has been previous work evaluating LLMs. Usually when models are released, they get released with a white paper that has some level of evaluation on common data sets. There are people outside of those that design them that evaluate them independently on other question answering and other such data sets. And they've even been evaluated in more specialized data sets, such as cryptology and medical examinations. Similarly, in the field of prompt engineering, previous work includes persona patterning, chain of thought prompting, prompting by example, expert prompting, etc. And there's even been work specifically looking into the effects and capabilities of personas, workflows for creating them, their abilities to embody human traits, and their abilities to enhance the performance of thematic analysis. Lastly, for multi-agent structures and question classification, there's some prior literature for this as well. These include solo performance prompting, roundtable, multi-agent styles, and multi-agent to debate styles. Lastly, in the realm of question classification, there are many taxonomies that have highly granular question classifications. And there's even some work that suggests that multiple choice and short answer questions measure different aspects of comprehension, which will be relevant later in our presentation. The research questions that we want to answer with this work are: how do expert personas perform on various question answering tasks? How do rudimentary multi-agent systems compare to similarly simple single-agent systems, and what question answering applications are personified LLMs best suited to answer? Our methodology for this was to curate a sufficient number of differing question data sets of different formats and different subject matter to denote our different styles of persona-based prompting, or persona-based prompting. Those four styles are the control, static persona, auto-generated experts, and multi-agent auto-generated experts. These will be elaborated in more detail in future slides. Then we had to build a framework for testing it. Each combination of style and data set had a random selection of at least 200 questions, and then analyzed the results. So the data sets we chose were Databricks, which is a mixed short answer data set. We also created a subset of this to focus on another attribute we'll point out later called openness. AI2ARC, which is a multiple choice grade level science question data set. Common Sense QA, which is another multiple choice data set that focuses on common sense questions. MMLU, which stands for Measuring Massive Multitask Language Understanding. This is also a varied multiple choice data set. It's very common for the evaluation of new models. Longform, which is a varied set of tasks generated from online sources. This is also short answer. A PubMed QA, which is both a short answer and a multiple choice data set. This one focusing on medical abstracts. And a FinTalk, which is a short answer data set of online financial advice. So in this paper, we identify an attribute that we call openness, and we quantify openness by two attributes, the first being the number of correct answers for any given question, and the second being a number of ways a correct answer can be correctly expressed. So abstract short answer questions would be considered high in openness because it can have many correct answers, and you can express those correct answers in many different ways. And then precise multiple choice questions would be low openness. So some data set examples for this, we take one question from Databricks, which is a species of fish, taupe, or rope. There are only two possible answers here, taupe or rope, and there's only one way you can express each, either by saying taupe or saying rope. So this is a very low openness question. Similarly, from the AI2 ARC dataset, this question, George wants to warm his hands by quickly rubbing them. Which skin surface would produce the most heat? This is a multiple choice question, so dry palms would be the only correct choice here, and the only way for selecting it would be to select the number that represents that one. So it would be 1, 2, 3, or 4. So this would be similarly a low openness question. On to some medium openness examples. Another example from Databricks, the question is, what is a verb? So in this one, there is ostensibly only one correct answer, similar to something like what you would see in a dictionary. The answer here is a verb is an action word that describes an activity, and then it falls to give some examples. However, you could express this correct answer in many different ways. For example, you could give different examples, or you could word the definition slightly differently. So we rate this as a medium openness question. The next example from the PubMed QA dataset, the question here is, are group 2 innate lymphoid cells increased in chronic rhinosinusitis with nasal polyps or eosinophilia? Not that I know what any of those words mean, really. But in this example, in the PubMed QA data set, the answers are either essentially a yes, no, or a maybe, and there is a short multiple choice question answer, which is the yes, no, or maybe, and then there is the long answer, the short response answer that has reasoning. And so the answer will be either yes, no, or maybe. There's only one correct answer, but there could be different reasoning and different ways to express that in the short answer version. So we rate this as an open, or as a medium openness question. Our last two examples here, the first one from the long form data set, the question is to describe redux data structures. And then it goes on to try to give a description of that. We rate this as high because not only could you express this in many different ways, but the description could focus on a portion of it, could focus more on could give a general overview, and then focus on a single portion. Could only be a partial description. And it could describe many different things about it. So there are many different correct answers when one asks to describe something, and many different ways that each one of those answers could be expressed. Similarly, from FinTalk, the question here is, what are some job ideas for a 62-year-old man with limited skills and qualifications, low confidence, and a failed business? The answer here is truck driving, but there could feasibly be many other options that would be valid answers here, and many ways to express those answers. So we rate this as a high openness question. When we did answer evaluation for multiple choice questions, they were simply graded based on the associated key. For free response questions, we utilized an LLM-based judge. There has been work that suggests that simply using an LLM-based judge to extract a numerical value grading a passage can be volatile or inconsistent. And so to circumvent that, what we do is we provide the judge the question, the correct answer, and then the answer to be graded. And instead of asking the judge to simply grade the answer on its correctness, we instruct it to quantify the semantic similarity between the correct answer and the given answer on a scale from 1 to 10. And through testing, we found this to be very consistent. Our 4 prompting styles, as we mentioned earlier, are the control. In this one, we simply tell the LLM they're taking a certain type of assessment and how it should be formatting its answers with no other instructions besides being given the question itself. With a fixed persona, we give it the same persona every time. In this case, something akin to act as an incredibly intelligent researcher who has all these myriad skills, and then we give it the same information as the control after that they're taking a certain assessment and how to format their answers. The third style is the auto-generated persona. This is explored in an earlier paper called expert prompting. What happens is that the LLM is given the question and instructed to detail a persona of an expert that would be able to answer the question. And then is instructed to act as that persona and then answer the question while acting as that persona. And the last one is our auto-generated persona roundtable, the multi-agent version. And this one I'll explain in the following slides. So for this version, the question goes both to an admin agent and a persona creator. This persona creator creates a list of experts to help in refining the answer for this question. The admin generates an initial answer and then passes that initial answer to the experts. And each expert will receive whatever the admin said, as well as whatever suggestions, comments, or other new answers that the previous experts had mentioned. And at the end of each round, the answer will be revised by the admin and then will be reviewed by the experts in additional time until a specified number of rounds have been completed. At the end of all of these rounds, the admin makes a final decision given all of the chat logs from all of the experts, and that is used for the final evaluation. As for our results, we found that persona-based systems, prompting systems, tend to perform better on questions that are higher in openness, and this applies even to more specialized domains such as finance and medicine, so that our respective data sets for this were PubMed, QA, and FinTalk. Additionally, we found that multi-agent systems require ancillary prompt engineering techniques to outperform similarly simple single-agent techniques, and that auto-generated expert personas show consistent improvement over the control across almost all data sets. And that's all I have for you. Thank you for watching, and questions are welcome.
Sorry for the interruption. Actually, your slides are not moving still.
Oh, were they not going that whole time?
Yeah, no, like it's like stuck in the first slide itself again.
Okay. Let me.
Yeah, you can just share your screen again, go to the slide where you have stopped.
Sure, 1 second.
Yeah.
So I'll try to quickly go over this then. Okay. For the sake of brevity, I'll skip the intro. I spoke about our methodology earlier. Curate data sets, denote the different styles, build a framework, and analyze the results. Our data sets that we use here are listed. The concept of openness that I mentioned earlier, that abstract and short answer questions are going to be higher in openness, and precise multiple choice questions are going to be lower in openness. And then our data set samples. So these are the low, These are the low openness samples that I mentioned earlier. So our first one being which is a species of fish, taupe or rope. There's like 2 possible answers here, only one that is correct and only one way to express it correctly. So this will be a low openness question. Our second one here from Databricks, what is a verb. There's ostensibly only one correct question or very similar or correct answer, or very similar correct answers, but there are many different ways to express them, different examples that you can give and such. This would be a medium openness question. And then the example from our high openness question. So from FinTalk, what are some good ideas for a 62-year-old man with these conditions? And the answer here was truck driving, but there could be feasibly many different answers for this, many different viable answers for this, and many different ways to express it. So it would be high openness. For answer evaluation, for multiple choice, we used answer keys that were included with data sets. And then for free response, we used an LLM judge that was specifically instructed to compare the semantic similarity of the correct answer and the given answer to avoid some issues with LLM judges that have been observed in prior literature. Our prompting styles are the control, where it simply gets the instructions on how to format its answers and its basic instructions on what to do. Fixed persona, which essentially has the same persona every time, that it's instructed to act as a generally competent individual with a myriad skills, and then told what to do. The auto-generated persona, where an LLM is first given the question and told to generate an expert that can answer the following question, and then to act as that persona while answering the question. And then lastly, the auto-generated persona roundtable. So to quickly go over this again, the question gets fed into the admin and an expert persona creator that creates a certain number of expert personas to help refine the answer. The admin creates an initial answer, and that initial answer gets fed into the expert roundtable, where each expert receives the answer as well as all of the feedback from the prior experts. Once all of this feedback has been accumulated, it goes back to the admin to revise the answer, and this repeats for a given number of rounds. After the final round is completed, the admin sees all of the feedback and generates one final answer, and that's used for the final grading. And for our results, we found that persona-based systems perform better on questions that are higher in openness, and this applies even to very specific domains such as finance and medicine. So the two data sets that we that this refers to are FinTalk and PubMed QA. And we also found that multi-agent systems require ancillary prompt engineering techniques to outperform other simple single-agent systems, and that auto-generated expert personas show consistent improvement over the control across all data sets. And all of that, you can see all the slides there, correct?
Thank you. And I would like to know if any questions and from forum. I hope there are no questions.
The future direction.
Yeah.
So you notice that the multi-agent technique that we use was actually fairly simple, and it lacked a few methods that are common to use, such as like voting, which is common in ensemble techniques. But there are a considerable number of ways that multi-agent systems can be constructed, and also that personas can be constructed. This was just one of many. And so future directions for this would be testing how additional constructions of multi-agent systems can work. I gave some examples in the literature review in the beginning, as well as measuring the performance of these in other systems such as retrieval augmented generation is another incredibly complex application that has many different moving parts, each of which has yet to be evaluated empirically.
Thank you. Thank you very much.